Okay, hello everyone. I hope you're all doing well. Okay. All right, so the next program in chapter 7 is Payroll Class. All right. Write a payroll class that uses the following arrays as fields. Employee ID is going to be an array of 7 integers to hold employee identification numbers. The array should be initialized with the following numbers. So these are the numbers that are going to be in the employee ID array. Also, this class is going to have the hours, which is going to be an array of 7 integers to hold the number of hours worked by each employee. PayRate is going to be an array of 7 doubles to hold each employee's hourly pay rate. And then wages is going to be an array of 7 doubles to hold each employee's gross wages. Okay, the class should relate the data in each array through the subscript. For example, the number in element 0 of the hours array should be the number of hours worked by the employee whose identification number is stored in element 0 of the employee ID array. That same employee's pay rate should be stored in element 0 of the pay rate array. And so basically all what this is saying is that, all the arrays are going to have the same number of elements. And so the element in index 0 of each of the arrays will basically refer to, let's say, the first employee, and the element in index 1 of each array is going to be basically all those elements are going to refer to the second employee. So that's what it's saying. The information about each employee should be all stored in the same slot, the same index of each array. All right. So in addition to the appropriate accessor and mutator methods, the class should have a method that accepts an employee's identification number as an argument and returns the gross pay for that employee. So demonstrate the class in a complete program that displays each employee's number and asks the user to enter the employee's hours and pay rate. It should then display each employee's identification number and gross wages. Input validation: do not accept negative values for hours or numbers less than $6 $6 for pay rate. All right, so basically we're going to create a class and with arrays and basically store the employee's hours, employee's pay rate, and then basically use the program to calculate the employee's wages and then have it displayed. Okay. All right, so we're going to have two files. One is going to have the class itself, and then the other one is going to be the program that's going to test the class. And so this file here is going to be where the class is going to be. So let's start. I'm going to go ahead and create a public class, and it's public because this is a class that everyone's going to want to create an object from. Right, so I'm making it public to available to the public, and then I'll call it payroll. And then now let's start by creating the fields. We have employee ID, which is going to be an array of 7 integers. So we know it's going to be an integer array called employee ID. And so I'm going to create a private. Before then, I had to reinstall my Dr. Java. So let me just change the indentation level to 4 characters or 4 spaces. I forgot where it is. Somewhere here. I'll see. Just a second. I think it's 2 by default. So anywhere I see 2, I know that's where it is. Yeah, right here. Change it to 4. Apply. Okay. So that means anytime I hit the tab, I get 4 spaces before it instead of 2. Before it here instead of 2, which is good. 1, 2, 3, 2, 3, 4. Okay, so now I'm going to create the fields. The first one is going to be the employee ID, which we know is going to be an array of 7 integers. So I'm going to create an integer array, but I'm going to make it private because I don't want code outside of this class to be able to directly access or directly change the content of this class. I don't want it to be able to directly see the content. I don't want it to be able to directly see the content of this field, and I don't want them to be able to directly see the content of this field. I want them to use other methods that we're about to, or other public methods that we're about to create to access the content of this field or be able to change the content of this field. So that's why I'm making it private. I'm hiding the data, the field. All right, so it's going to be a private integer array called employee ID. And it told us that we should actually initialize the values. It said the array should be initialized with the following numbers. And so we have the numbers we should initialize the array with. And if you want to initialize the array, we don't need the new keyword. We can just store in the numbers this way. Now the numbers have to be separated with commas, so I'm going to do just that. I just copied and pasted, so that's why I don't have my my commas. So now I'm going to just separate them with commas here. Oops. Okay. All right, so now I needed my semicolon to terminate it. So now I have the employee ID array initialized with values. All right, so we know that from the question, we know that each array is going to be made up of 7 elements, because there are 7 ID numbers to represent each employee. And so we know that each array is going to have 7 slots. Okay, they're all going to have the same size. And so just so we can actually use this value in the future, I'm going to create a variable which is going to be a final variable that's going to hold the number 7 being the length of this employee ID array. Okay, and I'm going to store it in a variable so we can use it in the future. And so I'm going to create a private field. Again, it's going to be a private field. It's going to be a final variable, which means a constant. It's going to be an integer, because it's just going to be the length of an array, which is just maybe 6 or 7 or 8 or 9. In this case, it's 7. So private final int, I'm going to call it number of employees. And since it's going to be a final variable, I'm going to use uppercase but separated with underscores, the word separated with underscores to create them. So number of employees this way. And I'm going to set it to, instead of hard coding it and typing 7 here, because if I do this, now what happens if I add one more number here? It wouldn't change it dynamically. So instead of typing in 7, I'm going to use the public field. Each array has a public field called length that tells you the length of that array. And so I can call employee ID directly. I can call the field. It's not a method, and that's why I don't put parentheses. It's just a field. It's a public field. The field that's public as opposed to this field that's private. Each array has a public field called length that you can just directly access the contents this way without using any public method to access it. You can just call employee.length and it returns the length of that array. In this case, I'm returning the length of employee. I'm using the length. I'm not returning it necessarily. I'm using the length of employee ID. And so we'll store it in number of employees. Now we can use number of employees in the future in the future, and you see that. Or one way you can use it is we can initialize the other arrays that we're about to create with this size, although we don't know the number of elements in there yet. We don't know the elements themselves in there, the values themselves in there yet. But we know the number of elements, which is 7, but we don't know the values itself. All right, so now let's go ahead and create the other arrays. We have hours array, right? So it's also going to be a private. It says ours says an array of 7 integers, also going to be an integers, right? So private integer array called hours, and we don't know the values, that's going to, or the values that the values that are going to be stored in this array, because the user is going to actually enter these values. They're going to type in their hours and then their pay rate. And so let's just create this variable which is going to store an integer array. It's not storing an integer array yet. It's just a variable that's going to store an integer array. Even though we know the size of the array, we can initialize the size of the array. We can set the size of the array now, but we don't have to do that now. We can do it when we are doing the constructor, when someone tries to create an object from this class. But that's all we can do for now, because we don't know the values themselves. Okay, the user is going to type in the values, and we're going to use those values to fill this hours array for each employee. So for now, let's not really set the size. We can set the size in the constructor. So I'm going to make a copy of this and repeat it for the other ones. We're just going to change a few things. All right, so private int is done. Now let's create payRate. But payRate is going to be an array of 7 doubles instead of integers doubles. And so private double, and it's going to be called payRate. And then we have wages, an array of 7 doubles to hold each employee's wages. So 7 doubles. It's also going to be an array of double, and it's going to be an array of doubles, and it's going to be called wages. All right. So now let's move on. Let's go ahead and create the constructor. Before anything else, let's create the constructor. So now the constructor is just like any other method, right? The only thing is it doesn't have the keyword static, and it also doesn't have a return type. Now it doesn't have a return type is because we don't call this method ourselves when someone tries to create an object from this class. And because we don't call this method, this constructor ourselves, it cannot return a value, and therefore we don't specify a return type, right? So no static keyword, and then no return type. It's just the access specifier. In this case, I'm going to say public. It's going to be public because this is the method that we want people to use to create an object from this class. So it's going to be public. And then now it's the access specifier and then the name of the constructor. Now the name of the constructor has to be the same as the name of the class. In this case, the name of my class is payroll, and so the constructor also has to be called payroll. Apart from that, it looks just like a regular method, right? No static keyword, no return type, public, access specifier, and then the name of the class, which is payroll. Now, what do I want this method to do when someone tries to create an object from this class? Well, first of all, the person is not going to pass in any argument, so I'm not going to specify any parameters here. But what I want to do is we know this employee field, the employee array is already initialized with values, but we want to initialize these. I mean, not necessarily initialize them because we don't know the values yet. We have to figure out those values. Hours and payRate are values that the user is going to enter, and we are going to use what's stored in hours and payRate to calculate the wages or fill the wages array. And so, even though we don't know the values that are going to be in these arrays, we know the size. We know the size is going to be 7 because we are actually dealing with information about 7 employees, right? Based on these values here. And so let's set the size, and we know the size is going to be dynamic. If we change the length of this, this is going to change because this is actually, dynamically taking the length of employee ID and storing it in number of employees. Okay, so we can use this number of employees to actually initialize these arrays. These variables are just created. They are created to just store arrays, right? But they are not storing the arrays, they are not storing the arrays right now. And so let's start actually, storing arrays in them. And so ours is designed to store an integer array. So ours now is going to be equal to a new integer array. Now we can set the size, and then we know the size is basically what's stored in number of employees, so we can use it. Do the same thing for the other ones. So next one is going to be a double array, which is payRate, and payRate we know is a double array. So we're creating a new double array, setting the size of it. And the next one is wages, and wages is a new double array here, and we're setting the size of it. And that's all the constructor is going to do. So we are done with the constructor. Okay, it's all just going to initialize the arrays that are not in. It's going to set the size of the arrays that are not initialized. All right, now I like to have my constructor as the last thing in the class. It doesn't matter where you put it. You can put it before your instance method or your regular your method, but I like to have mine as the last thing in the class, and so I'll keep it that way. And then I'll create everything else in between here after the fields. Okay, so let's see what we have to do. It says the class should relate data. Okay, that's fine. All right, so let's see. All right, so we will the user will, when the program starts in main, we'll write the program such that the user is going to type in and fill in the hours array by typing in the hours, and fill in the payRate array by typing in their payRate. But then we will have to calculate the wages. The wages is going to be based on what's stored in hours and what's stored in payRate, and so we have to calculate the wages and fill the wages array, okay, with values. And so let's create a loop here. Actually, before that, let's create a method that's going to do that for us. Let's create a method in the class that's going to do that for us, right? And so this method is going to be, well, before that, I'm going to go ahead and create a public method, okay? Public, because we want to make it public. We want anyone who tries to create an object from this class, basically any programmer, or basically anyone who uses this class, code outside of this class that tries to create, or that tries to use this method. We want to make this method available to that person. That's why we're making it public. Okay, so it's going to be public right now. This is going to be an instance method. Now, instance methods are methods that directly affect the field of an object created from this class. So if this method is going to directly affect these fields, then it's an instance method, right? And instance methods don't have the keyword static. Okay. For now, just know that instance methods don't have the keyword static, right? In chapter 8, you will learn more about it and why, and you learn more about static. But for now, just know that instance methods, okay, those are the methods that directly affect these fields, and they don't have the keyword static. But apart from that, they have everything else. They have a return type, everything else. So now let's specify the return type of this method. When you think about it, this method is going to calculate the wages, right? So it's really not going to return anything. It's just going to calculate the wages based on what's stored in hours and pay rate, and then store the result in wages. That's it. It's not going to really return anything. So let's set the return type to void, which means nothing, which means that it's returning nothing. And so public void, and let's call this calculate wages. Okay, this is the name we're just coming up. The program didn't really tell us. All it said is, in addition to the appropriate accessor and mutator methods, right? So it didn't really tell us the exact or specific methods we should create. All right, so public void calculate wages, and what we want to do is, first of all, iterate over how many times of employees. We want to start with the first employee, second employee, third, fourth, fifth, sixth, and seventh employee. And we want to calculate. Now you have to remember that the first item here, okay, is going to match the first item in the hours array. Okay, so basically this is the the first employee's ID. The first element in hours is going to be the hours for the first employee, and the first element in pay rate is going to be the pay rate for employee 1. The second employee, right, is this. The second item in hours is going to be the hours for employee 2, and the second item in pay rate is going to be the pay rate for employee 2. So the elements match each other, okay? They match each other. And so we're going to iterate over how many employees, and we're going to use an index to refer to them. And we're going to use a value stored in these hours and pay rate to calculate the wages, for each employee. And so let's create a loop that's going to iterate over however many employees. First of all, let's create an index. It's going to be an integer index. I'm going to call it employee index. Let's initialize it to 0. Right, now each array element has an index that represents it. So for example, for an array of 7 elements, the first element has an index of 0, second element has an index of 1, third element has an index of 2, and so on. This array has 7 elements, okay, 7 elements. And so the first element has an index of 0, and the last element has an index of 6. Although there are 7 elements, the last element has an index of 6, because the index starts counting from some 0. The first element will have an index of 1, and the 7th element will have an index of 6. And so for any array, the last index will always be 1 less than the length of the array. And so if you have an index that's less than the length of the array, then you are dealing with a valid index, because this array has 7 elements, right? It has a length of 7. How many items there are in this array? And so if you're talking about index 0, 1, 2, 3, 4, 5, 6, all those numbers 0 to 6, they're all less than the length of the array, which is 7 items. 1, 2, 3, 4, 5, 6, 7. And so in any array, if you have an index that's always less than the length of the array, that's a valid index. You can use that number to refer to an element in this array. But if you have an index that's over the length of the array, then that index is invalid. You won't be able to access an element in that array. And so again, we'll use the indices to refer to the elements in the array, and always the last index of any array is always going to be one less than the length of the array. Okay, there are 1, 2, 3, 4, 5, 6, 7 elements, right? And then the indices are 0, 1, 2, 3, 4, 5, 6. So although there are 7 elements, the last index is 6, and so the index will always be 1. The last index will always be 1 less than the length of the array. And so that's what we're doing here. We're starting the employee index from 0 and we're going to make sure that it's always less than the length of the array. And as long as it's less than the length of the array, as long as the index is less than the length of the array, then we know we have a valid index, and we can use that index to refer to an element in the array. if we make sure that we are always one less, make sure that that index is always less than, not even one less, not one less. We know that the highest index is always one less than the length of the array. But if we're making sure that our index is going to increase each time, but increase by 1 each time. But if we are making sure that our index is always less than less than the length of the array, then we know we're dealing with a valid index. Okay, so I hope I explained this well. Okay, I hope I didn't confuse anyone there. All right, so let's initialize employee index to 0, and as long as the employee index is less than the length of the array. Now the length of the array, we know that we can use the public field of every array, which is length, to refer to the length of an array, right? But here's the case, we are doing it here, okay? We are calling employee ID, we are using employee ID.length here, and then storing it in number of employees. So we can actually use number of employees, which is going to be the length of the employee ID array. We can. We know all the arrays are going to have 7 elements. We know the length of all the arrays are going to be 7, and that's going to be always stored here. Even though we are storing the length of the employee ID array in number of employees, we know the other arrays are going to always have the same number of items stored in the employee ID array. And so we can use number of employees here because it stores the length of basically all the arrays, right? Although it's just for this one, we know all the arrays are going to have the same length. And so let's use length of the number of employees, which kind of makes sense, right? It reads well. Let's say, so we are starting the employee index with 0, and we're making sure that employee index is always less than the number of employees, okay? Less than 7. Because if we have an index anywhere from 0 to 6, we can use any of those numbers to refer to the respective item in that array. All right, so as long we set an employee index to 0, as long as employee index is less than the number of employees, let's do what's in the loop. And before we come back up and check to see if employee index is less than the number of employees, let's increase employee index by 1. And so by doing this, we are always increasing the employee index by 1, starting from 0, increasing the employee index by 1, and making sure it's always less than the length of the array. Because in other words, we're starting from the first index, which is 0, to the last index, which is always going to be 1 less than the array. Over here, we're starting from the first index, which is 0, to 6. All right, 6 will be less than the length of the array, which is 7. And so we are starting from the first item to the last item. That's basically what we're doing here. In other words, we are going through the array. We're going through each element in the array and not going over it. And this is basically checking for us. It's a condition to check for us. We're starting from 0. Okay, I just wanted to make sure this is clear because we're going to be using it a lot. All right, and so we want to go through. All right, we are in actual sense we are using the indices, right, to go through any of the arrays because we know all of them are going to have 7 elements, right? So we can use this index to refer to any of the slots in these arrays. They're all going to have 7 elements. We can use index. If we use index 0, we are referring to the slots, the first element in each of these arrays. If index goes to 1, we are talking about the second element in each of these arrays. Okay. All right. So what we want to do is we want to go through the arrays, take the first element in hours, take the first element in payRate, multiply them because hours times payRate will give us a wage. Multiply them and store that result in the first element of wages. Now move to the second element of hours, move to the second element of payRate, multiply those two, hours and payRate, and then store the result in the second element of wages. Okay, because the second element here we are referring to the second employee. And basically we're going to do that, so on and so forth. So each time let's start with the first element. Employee index is 0. We are talking about the first slot, the first element, which has an index of 0. Basically the first lot of all these. What we want to do is we want to calculate the hours, right? So basically we are saying that so before the program starts, right, this will be filled. Before we call this calculate wages method, the hours array and the payRate array will be filled, and so we will have the values. And so what we want to do is we want to take what's stored in the hours array at that particular index, and so we are using employee index to refer to that particular index, and we are multiplying it with the particular index of payRate. Okay, we are using employee index to refer to that particular index, and that result, this is going to give us a result. We need a place to store it, and so we are storing that in that particular index of wages, and we are using employee index to refer to that particular index. And so if employee index starts from 0, wages 0 is referring to the first element in wages, and hours 0 is referring to the first element in hours, and pay rate 0 is referring to the pay rate, the first element in pay rate. And then employee index moves to 1, and then we're referring to the second element in each of these arrays. And then employee index moves to 2, and then we are referring to the third element in each of these arrays. And so that's exactly what we're doing. By doing this, we are basically calculating the wages and filling the wages array for each employee. All right, so now we're done with that method. All right, so let's move on and tackle the other ones. All right. Now it said, in addition to the appropriate accessor and mutator methods. Now we'll talk about those accessor and mutator methods in a second, but let's do the other ones. Let's do this. It said, in addition to the appropriate accessor and mutator methods, the class should have a method that accepts an employee's identification number as an argument and returns the gross pay for that employee, right? So let's create a method that's going to accept in an ID number, okay, any of these ID numbers, and it should look through the wages array based on that same slots to return the wages for that particular employee. And so if we are referring to the first element, that's the ID for the first employee. The wages for that particular employee will be stored in the first slot or the first element of the wages array. If we are referring to the fourth employee, which is 1, 2, 3, for the fourth employee, right? The wages for the fourth employee will be stored in the fourth element of the wages array. And so we can use a loop, okay? First we're going to go through the employee ID array to make sure that that employee exists. We are going to use employee index to keep track of the particular index we are on. Okay, we are going to always add 1, make sure we are always one less, or basically we are always less than the length of the array. We're going to go through each employee, make sure we find a match. And so if you find a match, employee index will actually hold a particular index of that particular element or that particular slot, okay, that particular employee ID. And so if we find that this ID matches what the user has provided as an argument, employee index will hold that particular index here. In this case, 0, 1, 2, 3. It's going to hold index 3. And so since it has index 3, being stored in employee index, we can basically say that return, or we can say that the elements at index 3 of the wages array is going to be the wages for this particular employee. And so that's how we're going to do that. All right. So that's also going to be an instance method. We want it to be public. It doesn't have a keyword static. It has a return type. Since it's going to return something, actually, let's bring this down a little bit. It's going to return something, right? And so the return type, right? So it's going to be public. Okay, let's note no static keyword. The return type, right? It's going to return wages. It says the class should have a method that accepts the employee's identification number as an argument. All right. And returns the gross pay for that employee. And so it's going to return the gross pay, which we know is going to be a double, just a regular double. Let's call it get wages get wages by ID. Actually, let's say get employee wages by ID. Okay, because you have to provide the ID for you to get the wages. Okay. The user is going to provide, it said over here, the class should have a method that accepts an employee's identification number as an argument. So the user is going to provide the identification number, which is an integer. The ID numbers are integers, and so let's define an integer parameter let's say employee ID. Let's call it employee ID given. Let's call it employee ID given. And so the user is going to pass in employee ID. Okay. And what we want to do is, first of all, check to see if that employee even exists first. Let's check to see if the employee exists. Because if the employee doesn't exist, then there's no wages to return for that employee. We have to return something else. But let's check to see if the employee ID exists. Actually, this loop here is going through it can go through any of the arrays, right, including the employee ID. So let's make a copy of it. Same here. Delete the content of it. We are starting the employee index with 0, making sure it's always less than the number of employees, doing what's in the loop. And before we come back up to check to see if employee index is less than the number of employees, let's add 1 to it. Okay. So in that sense, we are going through any of the arrays. Okay, so this time let's check. Let's have an if statement that says that if at any time, now employee index is referring to the index, okay? So if at any time employee ID, which is the array, this particular index of employee index is equal to, and I'm using double equals, 2 equals to compare. Right, I'm comparing and asking is what's on the right exactly or equivalent to what's on the left. All right, if I use 1 equals and I'm assigning, I'm using double equal sign to compare and saying is what's on the right equivalent to what's on the left. And so if the particular index here in employee ID is equal to the employee ID that was given. Okay, so if it's equal to the employee ID that was given, then that means that the user exists. So in that case, then return that same index. Okay, return the element stored in that same index. Okay, that employee index in the wages array, because employee index is being used to keep track of what element we are on in the employee ID array. And so if we find an ID, that same index is what we're going to use to find the wages for that particular employee in the wages array. And so if we find that employee, return the wages array. Return the wages array here. Okay, I mean, sorry, not return the wages array, but return that particular value stored in this index of the wages array. All right, now it's also possible that we wouldn't find the employee. It's possible that whatever data types wouldn't be equal to any of these. Okay, in that case, we need something to return, right? And so outside the for loop over here, outside the for loop that's going through the basically searching the employee array, because guess what? If any of these, if the return statement hits here, nothing below it is run again. The method or the loop is exited and the method is done. And so if I type in something here at the bottom here, once this statement is reached, this return statement is reached, that's it. This loop is done and this method is done. But if this loop finishes and it doesn't find a match or it doesn't find that employee, then it's going to continue running anything below here. Okay, so over here, anything below here is going to run when the wages are not returned, meaning when the employee is not found and there are no wages to return. So in that case, let's return -1 when we don't find any employee. Okay, now we'll use this -1 value to tell if there was no employee found. Okay, now once we call this method and it returns -1, we know that the employee ID that was given here was not found. And so we'll test to see this value, what is -1, to see if the employee exists or not. And if the employee doesn't exist, we will use this value to write something in main or do something in main. But if the employee exists, it will return the wages of that employee. Okay. All right. And so now we're done with this method. And I'm using -1 because -1 is not the valid index. Okay, you can't have a negative number as a valid index. Yeah. So that's one good reason to use a number like that. All right, you don't want to return something that looks like an index. So -1 surely tells you that, okay, this didn't find the employee, and so return -1. And we'll test on this value, and you see how we do that. How I do that. Okay. Now it says demonstrate the class in the program. Okay, so before that, let's create some accessor and mutator methods, okay, or getters and setters. All right, so I'm going to create them here.